basic magnetic control wiring that we're going to do using NEMA contactor and NEMA starter. So in this video, we're going to take a look at a few things that we want to address regarding our starters. So for starters here, I'm just going to do a real quick thing here. We're going to identify the NEMA terminal numbers that are here on our contactor itself. Okay, so we've got L1 and NEMA 1. That's the same terminal point. You're going to see that there are some actual connection points up top there. When we get into the labs, you'll be able to see that. We've got our line 2, our line 3 in here, and down at the bottom, we've got our T1, which is right, it tells us right there. We got our T2. That one's hard to see, and this one is our T3. Okay, and it just tells us right there. Okay, so those are our terminals going to our motor. These are the terminals that are going, and we're feeding this starter with. And then these, the 1, the 2, and the 3 are our field wiring for our control devices. Everything else is going to be done internally in this starter. We also have our field devices. We have a stop button or a start button here, which is a normally open contact point, usually. A push button, a momentary push button. So there's a return spring, putting it back into its regular position. And we also have a normally closed push button, which is, again, our normal operation here for this. So I'm going to show how this relates now directly to our overall wiring diagrams. Okay, so now we move into this here. I'm just going to move my pretty little picture, which is really awkward. I'm sorry. But it is nice. I hope this feels personal, a little bit more so. Okay, so now we're going to get into the wiring of this stuff. And let me draw my pen up again. So as we saw in our previous diagram of the actual contactor, L1, L2, and L3, those are the labels that we were given that we're going to be feeding our starter with to begin with. And we had our T1, T2, and T3 that will be feeding to the motor. Okay, they're the controlled mechanism from that. Now, I also want to just take a moment to identify something here. This, right in this area here, this would include all of our power. Okay, that is our power circuit. So now I've got a straight through with a line 1 all the way through our contact points, our overload sensors, and into the motor. And line 2, same thing, and line 3, same thing. Those are our power circuit. So now what I could do is I could just transition those to our block diagram that's found on the right-hand side. And I know that I've got 1, 2, and 3 conductors that I'm feeding in from my disconnect into the motor starter. I've got my line 1, I've got my line 2, and I've got my line 3. And from our starter, we're going down, and I've got 1, 2, and 3 conductors over here. I've got 1, 2, 3 conductors. That's my T1, T2, T3. Okay, I'm just making sure I'm sorting out my power circuits in general. Okay, now I'm just going to erase the that to get it out of our way, and I'm going to go back into drawing our circuit. Okay, we also identified on that previous slide, we identified that there was terminals. So line 1, if we go down here to after the disconnect, we're going to see that line 1 connects to our NEMA 1. That was that terminal that was co-located on our actual starter. So here's our line 1 that's going to start the whole thing, and it makes a direct connection already to our NEMA 1. That is going to be factory installed in a NEMA starter. We're also going to take a look over here. We know that on the back end of this, on the right-hand side, I'm going to have my line 2. Just because I don't incorporate a neutral with this one, I've got my line 2. This is across the line starter. So whatever we happen to have here, let's say it's a 600 volt starter. I'm going to put 600 volts in here, and we want to make sure that we do that because, and we also want to make sure that we use our frequency, because in a previous video, we took a look at the ratings that we need to watch out for. And the ratings for this would be our voltages and our frequency. And we got to identify if it's going to be AC or DC. Okay, now we've got that point over here. And another common thing that we saw in terminals 2 and we saw terminal 3 on that magnetic motor starter. Those we identified already, and they're going to be right over here. These are standard NEMA designated numbers for our magnetic motor starter, a basic magnetic motor starter. And then if we look at the factory wiring over here, it goes from our coil, our contactor coil, all the way through to our overload. So that's what's missing in this drawing here, which would normally be the case. Okay, and we just draw that in. We can identify that as our overload, and our overload is going to go all the way back to our NEMA 2. Normally, you wouldn't have to make this connection. This is pre-built in. It's pre-built into our motor starters of NEMA. Okay, that will be already connected internally. So those are connected. Now, what is not connected is our NEMA 2, NEMA 3, and NEMA 1. This is our basic template right here. Everything that we do for controls starts with this basic template for our NEMA starter. And if it was IEC, it's going to be the same basic template too. We're just going to do a slight adjustment to address what we need to do for internal connection. But other than that, this is our basic template. This is our start point. Okay, now we've got our momentary contacts down here, our field devices. Okay, that's what we need to wire to. So the first order of business is we usually try and create a schematic diagram. A schematic diagram to show how we're going to start this. And the way that we start our devices is we always follow sort of a logical understanding of how currents flow. So when we look at how to stop something, we're going to look at how we can de-energize or stop that current flow immediately right from the left. So when we do our design of our circuits, we always look at current flows from left to right. It just gives us a real good idea of keeping standard industry practice. So what that means is that we usually want to start our stops as close as possible to the left. I'm just going to change the color of that guy right there. Actually, you know what? I'm going to leave it like that for now. So I've got my stop. And then I need to incorporate a start. This is where I have some options. If I was to want to do a start and not use a holding contact, I can. That's now our start. So when I push that button down, it energizes, or it allows a current path to flow through all the way through here to energize this control relay here, which then closes all these sets of contacts. But the moment that I let go of that button, I'm going to de-energize the whole circuit. It no longer has a path to keep that coil energized. So the way that we can work around this is now to use a holding contact, which is right here already our standard numbers. It's always between 2 and 3, and 2 is the pivot point between our contactor and the relay or the contact. So right there. So the way to complete this all is to make this connection right here. So now when I push the start button, I'm just going to change this color here. When I push the start button, I've already got a path, a current path potential all the way through here. When I push that start button, now I have a current path here and all the way through, energizing my contact. Okay, energizing that relay, which now closes the contacts. Now, what I have to do in order to open those contacts is I have to de-energize that relay. But if I open this circuit now up top, I'm going to try and do this very delicately. Ooh, took out my terminal. So if I was to open that back up, I no longer have current flow here, but I still have a continuation of current flow through my holding contact. That's why we call this bad boy down here our holding contact. We can also call it a maintaining contact, a holding contact, or I don't know. I think those are the two main words that we use for that. Okay, but that's already pre-built into our starter. So now we've got an overall working circuit up here. I've got my stop and my starts. My stops I want to put in this general area over here. I'm going to call that our stop location. And over here, I have my start location. So just general areas, and we're going to get into that in the course a little bit more. And then down here, obviously, we've got our holding area. Okay, so what did we do? We connected a circuit here, but we just did this on paper. Now I got to make the wiring work itself out in the field. So the way that we do that is I'm going to use different colors. I'm going to take a look at what I did from my, and I might do this just a little bit more. No, I don't think I get a choice. Okay, from my 1 all the way to my stop button. I always want to try and flow from the left to the right. So I'm going to enter my devices on the left and I'm going to exit them on the right. Again, just standard convention to try and alleviate any confusion. So I went from my NEMA 1 and I'm going to my right-hand side, or sorry, the left-hand side of my stop button. Okay, I just did a quick, simple little drawing over there, and I use the colors. It really helps to try and separate these with colors. Okay, now once we get to that point here, now I go from my stop, and I'm going to go over to my start. Jeepers. Just going to redraw in my NEMA 1, seeing as it decided to disappear on me. Okay, and then from the right-hand side, as we just drew, I'm going to now take that and I'm going to go into the left-hand side of my normally open, which is my start button. That is now stays in the field. It doesn't have to run back. Okay, the quickest and easiest way to do that. Okay, just internal. But now I still got to do this one here. I got to make that connection from the left-hand side of my start button. I've got to take that all the way back to NEMA 3. So now the amount of wire that I have from my from my controller out to my field devices, I've got 1 and 2 conductors, but we're not done with the circuit yet. Now I'm going to go to the other side, the right-hand side of my start button, and I'm going to use a different color altogether. Okay, I'm going to use dark blue in there. My dark blue goes all the way back from my start button to NEMA 2. In here, all of this stuff is internally wired. So all I need to do is go from my start button to my NEMA 2. So the right-hand side of my start button to NEMA 2. Now I would also have to make sure that this is connected. However, as I said before, in our NEMA starters, that is going to be already done. In our IEC starters, we'll have to make that connection inside. It gives us some more versatility, but it's just something that we got to keep in mind. So what we've done now is we've created the wiring out to our field devices. We paralleled the start button with our NEMA 3 and NEMA 2 contact, which brings us all of our field wiring. So now when we take a look at the start stop station, how many wires did I have going out to the field? I had the yellow one, the dark blue one, and the red one. I now have 1, 2, and 3. I've got my NEMA 1. I've got what's coming back from my control. So I'm going to just say red for now. My red control. I can call it my start. I can call it my whatever you want to call it or identify it as. Just we need to make sure that we do on each end so you know what's what. And then on the other side here, that one goes back to our NEMA. I guess we could call that our NEMA 3 if we wanted to. And then this guy here is going to our NEMA 2. In our magnetic contactor, we have NEMA terminals 1, 2, and 3. We call this guy a 3-wire control. When we refer to 3-wire control, we refer to it as having a holding contact. It is now what we call low voltage control. Which means that if the power or the voltage drops in a brownout type condition, it's not going to have enough energy to hold that holding contact. The relay is going to drop out and it's going to save us some problems. But I'm going to have to push start button again when the power comes back on. So it's a really good thing for saving our motors from under voltage conditions. In the code book, we actually refer to this as under voltage protection. And most of our motors are going to have that type of protection. So this is just one way of doing a control. And we need to make sure that we're looking at the different aspects that we used inside of here for our very basic NEMA controls. I hope this helped.